Welcome, this is Algebra 2, Unit 2-3, Graphing Quadratics. I am going to be showing you 3 different ways to graph quadratics and 3 different equation formats that you can have quadratics in. This is still dealing with vertex form HK, and I just want to mention all quadratics have either a maximum point or a minimum point. And the way that I remember these is Max, I think, is a grumpy old man. And he's always frowning, because we all frown. I mean, it doesn't even need to be a man. It could be a grumpy old woman. I don't care. It's just the frown going down is a negative in the front of the equation. Okay? If it's positive out front, I think of Minnie Mouse. You know, she's always smiling, and she's got those big ears. And so, yeah, Minnie. Minnie is smiling and positive. Max, grumpy and frowny. Okay? Vertex is always the HK. That's the point that is the highest or the lowest. The maximum or minimum point is your vertex. Now, we're going to talk about zeros. Zeros in the equation is when it equals a 0, and you've got your x squareds over here and all the equation over here. You always, in a quadratic, if you have 3 terms, you always set it to 0 so that you can discover on the graph where it crosses the x-axis. That's what zeros mean, is where it's going to cross the x-axis. Now, realize you could have it cross in 2 places, like I drew up there, or you could actually have it cross in 1 place, just with the vertex right on the x-axis. Or you could even end up, as we've seen, in some circumstances where it doesn't touch the x-axis, and then it looks like that, and so there's no solution. Okay? No solution to the equation. If there's 1 solution, then it's touching at the vertex. If there's 2 solutions, then you know that it's looking more like that. Okay, so first thing I do when graphing in vertex form, you've already played with what the transformations do, so you probably can look at that and say it, but this is how I graph them. I bring down my h, remembering that that was a minus, so I know that if it's saying there was a +1, then it has to be a minus a -1, so I just switch the sign of it, taking it back. It was given to me like this, x +1, I know that's a minus h, and the k stays the same. So that's where my vertex is. That is the very first thing that I graph. I go over to -1, down to -2, and I put my point. Now I look at it. It is a positive, so I can picture in my mind's eye it's going to go up like this. The only other thing I have to adjust for is the 2. Now there's 2 different ways you could do this. You could plug values in and come out with your y value. Just go with your vertex, go on each side of your vertex, and maybe do it again. You know, they reflect, so you know all you have to do is plug in 2 points. So I would plug in, since my vertex is at -1, I'd plug in -2, and instead of plugging in 0, because I know my -2 will be the same, I would plug in -3. Now I'll reflect those over this. Ooh, I should have mentioned that. That is my fold line. That's what the parabola can actually be a mirror image of, and that's called the axis of symmetry. I should have mentioned it on the front page. All of these graphs will talk about the axis of symmetry. Okay, so we plug in -2. -2 plus 1 is -1, squared is 1, times 2 is 2, minus 2 is 0. Okay, -3 plus 1 is -2, -2 squared is 4, 4 times 2 is 8, 8 minus 2 is 6. So that tells me that over here at -2, I'm at 0, and at -3, I'm up here at 6. Now, I reflect those over that fold line, so I've got 0 and 6 right there. Now I go ahead and I connect them. Now, here's the other way you could have done it, other than plugging in points, is if you remember back to the parent function, you have to think through this one for a minute. Remember how we did the parent function, it was at 0, 0, then we'd go over 1, up 1, and then we'd go over 2, up 4, because parent function was just squaring your input. All you need to do if you've got a 2 in front is when you go over 1, go up 2. So from this point, I just go over 1, up 2, and I'm at the 0. I go over 2 and up 4, I multiply that 4 by 2, so I go over 2 and up 8, and I end up right there at 6. So you can do that either way. Just be able to explain to me when I'm watching you which way you're doing it. Okay, now we're given a graph and we're asked to find the equation in vertex form. Not hard at all, you guys. The first thing you want to look at is look for the vertex, your maximum point. Now we already know this is going to have a negative out front because it's got the frown. Now we take our vertex at the maximum point and plug it in for h and k. So right here for h, plug in a 2. Right here for k, we plug in a 2. Okay? Now for a, we have to solve. So you have to be given 1 point because you need to be able to plug in an x and a y value. This point that it goes through at negative 2, 6, that's your x is negative 2, your 6 is your y. So I can replace y with 6 and x with negative 2. And now I can just solve for a. Negative 2 minus 2 would be negative 4. Negative 4 squared would be 16. 16 plus 2 is 18. So I have 18a equals 6. Okay? I'm sorry. I did that totally wrong. Oh, I'm so sorry. Negative 4 squared is 16, but that should be where I stop because I'm solving for an a. I hope you guys caught me do that. Now we need to go up the PIMDAs. Okay, as soon as we have that value. So we subtract 2 from each side. And we get 4 equals a times 16. Okay? I'm sorry, that should be a negative 6 on the y. So that would be negative 8. Okay? Getting lots of problems here. The way I noticed that was I was looking at it thinking, when I solve this, I'm not going to get a negative number for my a, so it wouldn't be a frown. That's what made me start looking at that. Then I realized we're down here and y is negative 6 down here. So now when we divide by 16, because you're just going up your PIMDAs, you get a equals negative 8/16. So a equals negative 1/2. Okay? So, So, now we come back to our minus a x minus h squared plus k equals y, and our negative 1/2 goes right here in front. We can see it should be a negative because it's a frown. The h value again is 2, and the k value is 2. And that's finding the rule for the graph. You always should have your x and your y left so that people can plug in points to see where else it'll be on the graph. Okay, a function rule has x and y left in there. But the h, the k, and the a should all be filled in. Okay, now we're given a bridge support. I'm just going to tell you up front, if you have a problem that's giving you vertex form, they're either going to want to know a maximum height, or they're wanting to know the time to get to the maximum height, or possibly the width of it. Okay, so the first thing we want to do is just kind of sketch it so that we're picturing it in our mind. We've got some kind of a bridge support going here. And right at the top, we know we're at 300, 150. So right there, if you think about how your graph goes, you know that the maximum height is 150. So 150 feet, I'm assuming it was in feet. I'm sorry, I left off the units. They ask, what's the width on the bridge deck? Well, if we come down here, we know that this is at 300. So we can assume that that's 300 there. We know parabolas are symmetrical. So that would be 300 there. So our maximum width on the bridge deck of this support is 600 feet. And you're basically done with the problem. The word problems in quadratics and a lot of these kind of things, as soon as you step into them, you really don't have a lot of math left. So come to class with questions.